Today, our concern is with the logistic regression analysis. In the previous video, we discussed the linear regression when we have two continuous variable. This time, we are working with the logistic regression, which demands basically the outcome variable, or we say dependent variable, is a dichotomous. Dichotomous means it has two categories: a binary variable. The independent variable can be of any time any type, but the outcome variable have two categories. For example, our dependent variable is lung cancer, having a lung cancer or not. So at this moment, when our dependent variable is categorical, we apply logistic regression. So the major requirement for logistic regression is that dependent variable is categorical type. In this video, we are working with the categorical type, which has two categories, and independent variable can be of any type, either continuous like age, discrete like family size, nominal like gender, male, female, ordinal like education status, for example, school education, graduate, postgraduate, doctorate, etc. In the linear regression, we worked out on the mean of the variable. There in regression, in logistic regression, we work out with the coefficient as odd ratio, which is a measure of association between the exposure and outcome variable. For example, like when we want to actually interpret the odd ratio, it implies that the odd ratio represent the odds, chances, probability, likelihood, etc. that an outcome will occur in the presence of exposure compared to the odds of the outcome occurring in the absence of that exposure. For example, in our first example, let's suppose our outcome is having lung cancer, our exposure is smokers, and our non-exposure, the absence of exposure is the non-smoker. So odd ratio will imply the chances of having lung cancer in smokers compared to the chances or probability of lung cancer in non-smoker. In our second example, for example, let's say the death is our outcome variable, and survival and the patient who were victimized with COVID, they are our exposure, and the non-exposure are non-COVID patients. So we will say the interpretation of the odd ratio would be like the likelihood of the death, which is our outcome, in COVID victim, which is our exposure, compared to the chances of death, which is our outcome, in non-COVID patient, which are non-exposure. The interpretation odd ratio also rely on the value of odd ratio. It can be it lies from 0 to infinity. So if the odd ratio is equal to 1 or around 1, we will say that the exposure does not affect the odds of the outcome. For example, if the odd ratio is around 1, in our first example, which we discussed in our previous slide, it implies that smoking does not cause the lung cancer, and or let's say COVID infection does not lead to the death. But in if the odd ratio is more than 1, so we will say there is a positive correlation between the exposure and the outcome. So for example, if the odd ratio come out to be 3.7, we will say smoker has 3.7 times higher odds of having lung cancer as compared to the non-smokers. And similarly, if odd ratio is 1.5, there between 1 to 2 or 0 to 1, the interpretation can be done in two ways. Either you can simply say, okay, COVID victim has 1.5 times more chances of dying as compared to non-COVID victim, or we can also do it like subtracting the value after decimal with the 1 and multiply by 100. So we will say COVID victim had 50%, 0.5, 50% had more chances of dying as compared to non-COVID victim. If the odd ratio is less than equal to 1, so we will say exposure is negatively associated with the low odds of the outcome. So we will say, for example, if the odd ratio come out to be 0.7, we will say smoker has 30% less likely to have lung cancer as compared to non-smoker. If the odd ratio come out to be 0.5, we will say, for example, COVID victim had 50% less chances of dying as compared to non-COVID victim. In this scenario, we are working with logistic regression with two variable basically. This is a published article also to find out the association of the chewing betel nut with the chances of coronary artery disease. So we have two variable at this moment, that our outcome variable is status of coronary artery disease with two variable, either non-cat or cat, and our exposure is showing beta line. For this, we will go to the SPSS, and we can see that our outcome. This was basically a case control study. So non-cat patient were our participant, and the coronary artery disease were the cases. And the at this moment, our independent variable, our exposure has two category also, means those who did not chew betel nut in their life, and those who chew betel nut in their life. So we will apply the logistic regression using the SPSS, going to analyze and regression, and then binary logistic. In the binary logistic box, we will transfer the cat status into the dependent variable list, and chewing betel nut in the covariate list. And since betel nut is our categorical variable, we have to specify that betel nut is our categorical variable, and we want to interpret the yes category based on the no category, which is our first category, no. So we will take the first, we will select the first and change the indicator, like changing the reference category from last to first. We will press continue, we will press OK. The SPSS will produce too many table. For this video, we are focusing on three table, which is dependent variable coding, categorical variable coding, and one last variable in the equation. The dependent variable coding is indicating that our outcome variable is coronary artery disease, and non-outcome is the non-coronary artery disease patient. And the in the exposure, our chewing betel nut is the exposure variable based on non-exposure, which is the non-chewer of the betel nut. So we have two category. We will obtain only one odd ratio, which is given here. This last column, exponential beta, is the column of the odd ratio, which come out to be 6.401. This 6.401 now indicates that with the chances of having coronary artery disease among beta nut chewer is 6.4 times high as compared to the participant who did not chew betel nut. Our next example, we will take the another variable, which is socioeconomic status. This is a category in the variable: low, middle, and high. The purpose of this is that this three categorized variable, we have to make one variable as a baseline, one category as baseline, and the other two variable will be for the other two variable, the odd ratio will be produced. So this will be clear when we run the logistic regression analysis. Like again, analyze regression in binary logistic, and we will put the socioeconomic status in our box, clicking on the categorical. We'll transfer this one, and we want to make the low class as our reference category, and we will interpret the odd ratio for the middle class and the high class. We will press on the continue. I will press OK. And these are the exponential. Okay, sorry. Dependent variable coding say the cat is our outcome variable, and the low class is the reference category. It has 0 in both. And first odd ratio will represent the middle class, and the second odd ratio will represent the high class based on the low class category. So here you can see we have two odd ratio mainly. One is exponential b 1.1 one is 1.406 and 1.240, and this 1.403 is for the first category in the table, which is mentioned in the categorical variable coding: 1 for middle class, 2 for the high class. So one is for first is for the middle class, so 1.406 is the odd ratio for the middle class, implying that the chances of having coronary artery disease among the middle class are 1.4 times higher as compared to the low class. Similarly, we can interpret the odd ratio of a high class, which is 1.240. We can also interpret it like this: the chances of having coronary artery disease in the high class is 24% higher as compared to the low class. There's one more thing which we want to show is that how to produce the confidence interval for the odd ratio and how can we interpret the outcome when we will take both variable as categorical. The confidence interval for odd ratio can be obtained by using the C option in CI for exponential beta. Press continue, and OK. So the two variable are in the table now with the same interpretation as like here. The first is for the middle class, second is for the high class, and this is for the chewing beta nut. So we can say 1.221 implies with this odd ratio is here. So 1.221 implies there is 22% higher chances of having coronary artery disease in the middle class as compared to the low class, keeping the keeping the other variable constant. Similarly, high class has twice likely to produce coronary disease, to endure coronary disease as compared to the low class. And similarly here, the beta nut chewer has 6.696 higher chances of having coronary disease as compared to the low class. This is a lecture for